Okay, how are you going with these? Are you ready for a challenge? I'm still in chapter 9, number 19. It's rated 3 stars for a reason. It's a bit of a doozy. In fact, Albert's got the coffee at the ready because he's a bit worried about how difficult this is going to be, but we're going to give it a go. Of course, I prepared one earlier, so I know I can do it. I wasn't going to muck it up in front of you. Okay, so in all of these questions, the idea is to try and make what looks pretty complicated into something simpler. And you often end up starting at the furthest end away from the battery. So if we look here, we've got 2 resistors here in parallel, and we've got some, not in parallel, in series, sorry. 2 resistors here in series. Then we've got these parallel bits. And now the devils have thrown in some other bits here that are actually forming little bits of series in the circuit. So we'll start up this end. We'll have a look here. And this bit here is actually 2 resistors in series, a 20 and a 10. So that means that this bit here is going to be 10 plus 20. This is actually 30 ohms. Right, so 10 plus 20, 30. All right, so we've got this section of the circuit, and it has told us that we've got a 1 amp current going through it. So this section here is actually in parallel to that 15. So we've got the 15. And I'm going to replace the 10 and the 20 with a 30 because I want to make it look a bit simpler. 30, 15. And we know that this has got 1 amp in it. So if I've got the current coming along here and it's splitting, 1 amp's going to go through the 30, 2 amps will go through the 15. 1 times 30 is 30, 2 times 15 is 30. So that's the way the current's going to split up. So that means before it's split up, that we must have had 3 amps. So either side here, we've got 3 amps. All right. I'm going to try and collapse this down now to make it simpler again. That's going to be the goal over and over again, is to make it a bit simpler. So we've just got, I won't draw it yet. I'll do this first. 15 and 30 in parallel, so it's 1 over R is 1 over R1 plus 1 over R2. So 1 over 15, 1 over 30, that's 3/30. So R would be 30 over 3, so R is 10. Righto, so I'm going to replace these two now with a 10. So this part is going to be replaced by a 10 ohm resistor. So now I've got that's my replacement. So this is 10 and this is 5. Now we established before that there was 3 amps here at this spot. 3 amps there, and there was 3 amps there. So we've got 3 amps going through here. I'm going to do the same thing as we did up here and work out what the current is going to be in this bit. So again, what we've actually got here is 2 resistors in series. in parallel to this third resistor. So these are in series, 5 and 10, just replace them with 15 ohms. 5 plus 10 is 15. So that bit is worth 15 ohms. If I've got 3 amps flowing through 15 ohms, what will flow through the 60 ohm? So you can do it in shares if the share idea works for you, the ratio. So you'd have 60 is to 15. So 4 is to 1. So that means I need 5 shares. And those shares will break up so that the 60 is going to get 1 share and the 15 will get 4 shares. We know what that 4 shares is worth. It's worth 3 amps. So if 4 shares is 3 amps, then 1 share is 3 divided by 4, 0.75 amps. That's one way to do it. The other way to do it is to use V equals IR. So we've got R and I. So V equals IR. 3 by 15 equals 45. This has to be the same. So V equals IR again. We know the voltage drop has to be the same across this part as it was across that part. So 45 equals I times R, which is 60. So I is 0.75. So you get the same, same either way. 0.75 amps. .5 volts. Rightio, so 0.75. Okay, so that means we've got 0.75 in here, we've got 3 in here, so here, and here, before the current split up, we had 3.75 amps. Righto, that may or may not be useful. We'll see in a minute. Righto, so I want to do the old collapse this down and replace it with 1 now. So what have we got? 1 on R equals 1 on R1 plus 1 on R2, 1 on 60 plus 1 on 10. I've run out. I'm going to have to go down here, sorry. I can only see certain part of the page at a time, so I'm wiggling all over the place. All right, so I just made a mistake if you were watching carefully. I've gone 1 on 10 because that was 10, but this is 15. So it's not 1 on 10, it's 1 on 15. So 1 on R is 5 on 60, and when you flip that up the other way, you get 12. All right, so I could replace this part with a 12 ohm resistor, and now my circuit is reduced down. I'm putting in a 12 there. I've got 40 and another 40 there. Rightio, so the resistance is going to be combined resistance. You just need to add them all together. 12 plus 40 plus 40, because they're in series, we just add the numbers straight together. 92 ohms. That's what the question actually asks. It doesn't ask, which I thought it probably could have, what the voltage is here. So we could work that out because we know 3.75 is the current that's flowing through here. We've got the resistance, we've got the current, so it's just V equals IR to work out the voltage from the battery. $345 volts. That's a really hard question. So if you understand that and it all made sense to you, well done.